Vectors are like other numbers and things that we have in math, and so we can add them and we can multiply by them. So I'm starting with my first definition of vector addition with scalar multiplication. So first of all, I had to define some vectors. So I'm going to have u, and that's going to be u1, u2, v, which is going to be v1 and v2, and then I'm going to have c is a scalar. So c is just a number, it has no direction, whereas these are vectors and they have direction. So the first definition is the vector sum. And so the sum of u and v is the vector u plus v. And we did this in the practice, an example before, is just adding the components. A scalar multiple So a scalar multiple, if I take c and I multiply it by u, it's the same as multiplying each of the components by c. Sorry, u2. And a negative, the negative of a vector, so like negative u, is the same as just negative 1 times u, which is negative u1, negative u2. And actually, this is the vectors in the opposite direction of u. And the difference of u and v is u minus v, which is u1 minus v1 and u2 minus v2. The next thing we're going to do is we're going to do a theorem. It's the properties of vector operations. So I have u, v, and w are vectors, and c and d are scalars. And so I know that u plus v is v plus u. This is a commutative property. I know that u plus v plus w is u plus v plus w. That's the associative property. I know that u plus that 0 vector, which has no size, is just u. That's an additive identity. I have additive inverse. If I add u and it's negative, it equals a 0 vector. I have, if I multiply c times d times u, it's the same as c times d, and then multiply it by u, so scalars. And then I also know that I can distribute. If I have two scalars, c plus d times u, it's the same as cu plus du, the distributive property. And I also know that if I have c times the sum of two vectors, it's the same as multiplying c times each of those vectors. And of course, the scalar 1 times u is just u, and the scalar 0 times u is the 0 vector. And the last little theorem we have is the length of a scalar multiple. So I have v as a vector, and c is a scalar. Then I know that the magnitude of c times the vector v is the same as the absolute value of c times the magnitude of v itself.